Hello everyone, this is Dipali. Welcome to my YouTube channel. So today I will tell about tensor. So I think most of the people already searched in the Google what is tensor, but very less people understand why just Google definition. In Google you got tensor is just array of numbers. So in simple words, tensor is just a mathematical tool that has application in theoretical physics, general relativity, and so more. So basically tensor helps to write large number of equation into less number of equation, and this someone asks what is the most useful property of tensor, that I will say that it just helps to save scientists researchers time, because if there is no tensor then researcher have to write that equation many times. So that's the most useful property. So in simple, it's just a mathematical tool, and there are other definition also, like that follows some transformation property under coordinate transformation. You will get this meaning of this definition later in this video. So right now just remember, helps to write large number of equation into less number of equation. So this is the equation. This is Einstein field equation. So most of the people think this is one equation. No, but actually it contains 10 partial differential equation. So with the help of tensor, I write 10 partial differential equation in terms of one equation. That's the most useful property because if there is no tensor, then you can imagine 10 partial differentiation equation is written in board to understand general relativity. But with the help of tensor, I write 10 partial differential equation only in terms of one. Okay, you will get to know what is nu v index, this g nu v is Einstein tensor index, like index. So in this video mostly I cover about index, because index is the basis of tensor. Without index no one understand tensor, so one must have the complete knowledge of these indexes. So in the what is this del nu f nu nu? So actually everyone knows Maxwell equations in vacuum. This is in the vacuum. Okay, so this equation contains all these Maxwell equations. So see how I write Maxwell equation in terms of only this small expression. Even I will prove that how you can write this equation in this, I will prove in my later videos. So no indexes, that's the main thing. So there are two types of indexes. One is free index. So what is free index? So the index which is present in left hand side as well as right hand side. So means like both side is depend on this index. So in this example you can see I is present in left hand side, I is present on right hand side as well. So means your left hand side is dependent on I, RHS is also dependent on this. So I call this I as free index. So I is free index. Now what is dummy index? Dummy index which is present only in one side. Like if it is present in RHS, then LHS is independent of it. Like okay, so like, and it is always present in one subscript and one superscript. In one variable it acts as subscript. It, if it is below we call that subscript. It is above we call as superscript. So you can see J is present below and here J is present above. So here J is dummy index. Okay, and in LHS there is no J. J is the index. Okay, LHS is independent of J. So we can replace this J with some other variable also. I can write L in place of J also. Okay, your LHS remains same. So we call J as a dummy index, I is free index. Okay, I left hand side and right hand side. So like remember that free index is always equal in LHS and RHS. Take more example. First try to expand this. Okay, everyone knows how to expand this. Let I can take three values. I can take three value 1 to 3. Okay, for I is equal to 1. V1, I expand summation later. Okay. Okay, now I am expanding summation. C11, A1, C12, A2, C3, A3. So I got this one equation for I is equal to 1. Same if I put I is equal to 2, I get second equation B2. So I similarly I got B2 and similarly I got B3. So everyone can see with the help of these indexes I write these three equations V1, B2, B3 in terms of this. So see that's the beauty now everyone understand I say that how tensor helps to reduce the time of the researchers because like we can write this equation in terms of this. Okay, let's take this example. So BMK, so it has two indexes. So any variable which has two indexes, we call it as a matrix. Maybe most of the people know it is a rank 2 tensor. And how many elements is in matrix? There are like if M can take three values. Okay, if M can take three values, 1, 2, 3, and K also can take three values. So how many equation you can get? How many equation? Like take the combination you get b11 b12 b13 b21 b22 b23 so you got total 9 equation and how many elements in 3 by 3 matrix 9 elements so that's the beauty so we call 2 by 2 2 by 2 rank 2 by 2 rank is matrix because of this in general 3D coordinates because in 3D coordinate there are x, y, z. So like so here M and K is free variable free index and IJ is dummy index because here see I is in one subscript and one superscript, J is one subscript and one superscript. So IJ is dummy index, MK is free index. Okay, now I expand only one. Okay, now let I take m is equal to 1, k is equal to 1. Okay, you got 9 equation. Okay, so I am expanding only one equation. Chalo, I expand this summation later. So m, now I am expanding this summation. First I am expanding j. Okay, I remain same 1 k I 1 I 2 k 2 plus I 1 D 3 A I 3. Now I have to expand I. So in one term you got 3 like I first I is equal to 1. I take summation I initially in this one term like in one term you got 3 terms because here I is equal to 1 then I is equal to 2 I is equal to 3 so you got 3 terms in one term here also you got 3 terms I just expanding summation C 3 1 D 1 okay sorry k is equal to k I have to put 1 okay so k is up पे 1 कर देना 1 2 3 1 okay now I am expanding second with I so everyone can expand this is very easy expand okay and so on similarly you have to take summation in third term so you got 9 terms in one equation so see with the help of tensor I write so many equation like you got 9 equation 1 1 2 1 2233, and each equation contains 9 terms. But with the help of tensor, I write these 9 equation in terms of this. Okay, and one important thing, it is not important that every quantity that have indexes are tensor. Okay, I will explain this definition later, but just remember right now, it is not necessary any quantity that have indexes are surely a tensor. I will even prove this, taking some example. Okay, next is Einstein summation convention. Okay, so in the starting of the lecture, I told like socially scientists are lazy. They try to find some way to reduce their time, like save their time. So one is also Einstein summation. Like Einstein's thought, why I have to write this summation many times? Like I am really like feel so much tired. Like I have to write this summation many times. So what he has done, he found like if there is one subscript, one superscript, then I can remove this summation. Like matlab not remove actually. Just I can assume that there is no summation. Like I can write this in terms of this. Okay, like just remove summation. It does not mean like summation is removed. Actually summation is there, but if there is one superscript and one subscript, one have to assume that there is actually a summation. Like if you expand this, then it remains same, like bi v1, then say cj aj, and if you take summation this, so same as this. So just it does not mean that you don't have to sum, like sum of all of these. You have to sum, but you don't need to write this summation sign. Okay, just don't need to write summation sign, but while doing calculation you have to do summation if there is one superscript and one subscript. Okay, that's the Einstein summation convention. So that's some exercise. So first is identify the free and dummy index. First A part, A alpha, B alpha. So here alpha is dummy index. How? There is no LHS, and I can replace it is in one superscript and one subscript. So alpha is dummy index. I can replace alpha with another variable, and I can also write this in summation alpha A, beta A, and like A1 B1 plus A2 B2 plus A3 B3. So I only get one equation. So here I get only one equation in A part. Okay, because there is no LHS and no B part. A dash alpha. So in B part, alpha is free index, beta is dummy index because beta comes in one superscript and one subscript. So first, like everyone know how to expand this. Okay, if one I expand, so let's take alpha is equal to 1. C1 1 beta 1. See, there is no summation, but in previous like slide I tell about Einstein summation removal. Like you have to assume there is summation, so you have to add this. Okay, C1 3A3. So you got one equation, and similarly alpha is equal to 2. You got second equation, and alpha is equal to 3. You got third equation. To total 3 equation one can got in B part. Okay, and the C part. So C part is homework. Okay, okay, but I will tell some what basics you must have to do. Hmm. Okay, I will done C part. C part is T alpha beta gamma A alpha C beta I D gamma I. Hmm. Okay, so here gamma is free index because gamma is present in LHS as well as RHS, and alpha beta is dummy index. It is present only in one side and it is replaceable. So now how many equation one can got? Every variable can take three values, 1 to 3. So see, gamma can take 1, 2, 3 values. I can take 1, 2, 3 values. So this is actually rank 2 tensor. So when you put alpha 1, 1, 1, 2, 1, 3, so everyone can got 9 equations. Okay, and alpha beta, everyone know how to add this. Alpha beta, this one subscript, one superscript. So one have to add. This is just a rank 2 tensor example like I done previously also. So it's very easy. So you got 9 equation. Next part is also exercise. It's very simple. Just okay. So a part I am doing. First a alpha, b alpha value is a1, b1 plus a2, b2 plus a3, b3. Okay, a1 value given, v1 value given, just add, put, you got the final. It's the most easiest question to be honest. Okay, in second part, a alpha, c alpha, beta. Okay, so for beta is equal to 1 to 3 means first for beta is equal to 1, you got one equation. Okay, no, you have to use Einstein summation, c11, c21 plus C31, put here you got first value at 4, beta is equal to 2, you got another value. So at beta is equal to 3, you got another value. These are some exercise question. So rank of tensor, so I am telling about indexes. I am also telling rank somewhat, but I did not explain much. So rank tensor, like it is just number of free indexes. Number of free indexes. Okay. So rank 0 scalar, rank 0 tensor means if any quantity has no index like 5, 4, 8, okay? Any quantity which have no index we call as scalar, okay? And that always remains same under coordinate transformation means that value always remains same, okay? We call it scalar like 5, anything that has no index, no free index, okay? Next is rank 1 tensor. Rank 1 tensor means 1 free index. Take an example of this. AI. Okay. So this is rank 1 tensor because here I is 1 free index. So rank 1 tensor. So in 3D we call rank 1 tensor generally as a vector. Okay. When you put x, y, z, one go this in terms of this C1, C2, A2, C3, A, sorry I have to mistake, AI is equal to 1 आएगा, okay, and so on. So one can get rank 1 tensor we call as vector in 3D and rank 2 tensor we call matrices, 9 elements. Okay, and there are also rank 3 tensor with 3 indexes. Okay, so for today that's enough. In next class, I will tell about coordinate transformation, how this vector, how this tensor change under coordinate transformation, and that is very important because in today I just clear about indexes, but main property of tensor comes in its coordinate transformation. Okay, so please like, share, and subscribe my channel. Thank you.